Hello, welcome to Algebra 1A. We're going to be working on lesson 1.1, the first lesson for all of Algebra 1A, so welcome. We're going to start with our objective. What we're trying to accomplish today is solving an equation. So you're solving multi-step equations. Before we get to multi-step equations, of course, we're going to go to one-step equations. Now, to understand this process is you're going to look at a minor scale. So I have a picture of a minor scale here, a little drawing. So if you've seen one of these before, how it works is if the two plates that hold the weight are at the same height, then they are equal. If it's going to be at different heights, they're not equal. So you want to make it to where they're the same height. So here, they are the same height. So if I were to add, or actually subtract 1 pound from the right side and get 2 pounds instead, how would I make them equal again is how you got to think of this. So I would make it equal again by either adding 1 pound here, or if I erase this, I can actually subtract 1 pound here. So, and this is how we can make it equal. So, okay, so we already talked about what we should do to make it equal. So once you understand that, you have to take some rules from this idea. So if I were to have 3 pounds, 3 pounds, we notice that if I add 1 pound here, I have to add 1 pound here in order for it to be 4 pounds and 4 pounds. So basically what you do to one side, you have to do to the other to make it equal. Okay? So the other is, well, let's go to the review actually. So if we look at a negative times a negative, we know that equals a positive. This should be review. A positive times a negative is equal to a negative. A negative times a positive is equal to a negative. Now there's a few ways to remember how to do this. So we can think of it as a bad guy with bad girl equals good thing, bad guy with good girl equals bad thing. All of those things are to remember that it's, if you have a negative times a negative, positive. Negative times a positive, negative. The other thing to remember, to help you remember, is you can use a triangle. So you have a negative, negative, positive in a triangle. This is called, some teachers call it Mr. Moody for multiplication and division, because this is where you're using the rules, multiplication and division. So you have this triangle here, negative, negative, and a positive. So if you multiply a negative times a negative, you'll get a positive. So something like negative 2 times negative 3, I know that 2 and 3 is 6. What's a negative times a negative? Look down here, positive. Okay, all review. Okay, next review. Fraction equals fraction, you have to cross multiply. So look at this. This is your problem. X over 7 equals 3 over 1 is your problem. So if you have a fraction equal to a fraction, you need to cross multiply. So what is 1 times x? 1x. What is 7 times 3? 21. X equals 21. Okay, and then in class we would be doing a multiplication chart. So be ready to do that in other class sessions when you attend. Practice one-step equations. So let's do the odd problems and you can do the even. So this is a handout you should have. If you do not have the handout, feel free to pause the video and work out the problems. Copy them down and work them out. Okay, in order to do these problems, what you want to look at is asking yourself two questions. What is the operation? What is the inverse operation? And then you work it out. So let's try on, we're going to do all the odds. So what's the operation? Addition. What's the inverse operation? Subtraction. Oh, third question, what do I want to move? Move the 3. So x equals 6 minus 3, 3. And we're done. What is the operation? Subtraction. What is the inverse operation? Addition. What do I want to move? The 2. We do to one side, do to the other, so x equals negative 2 plus 2. If you have a hard time with it, write it out. 2 negatives, 2 positives, so negative, or 1 minus 1 is 0, 1 minus 1 is 0. What is left? Nothing. 0 is your answer. Okay. 2x equals 6. 2x, when it's close like that, what is the operation? Multiplication. What is the inverse operation? Division. What number do I want to move? The 2. Put it to both sides. 2 goes into 6. How many times? 3. We are done. That was too fast. Great thing about a video, always just rewind. Okay? All right. Let's go to the next 3. Okay, what is the operation? It's really close. Negative 4 times x. Inverse operation, division. So we're going to divide by, what's the number? Is it 4? Nope. Make sure it's negative 4 when you're dividing. So we're dividing by negative 4. Here's the review. What is a negative divided by a negative? So if we need to, write Mr. Moody. You have negative, negative, positive. We have 2 negatives. It must be a positive. 4 goes into 16 how many times? 4. Answer is positive 4. So these are the one-step equations. Fraction equals fraction. We're going to cross multiply. 1 times x, 1x. 5 times 4, 20. 1 times x is the same as x. X equals 20. Okay, x over negative 2 equals 4. On this kind of problem, what you want to do is make sure that this is a fraction. So your question is, how do I make this into a fraction? What should I put on the bottom? Always put a 1. So now we have 4 over 1 and cross multiply. 1 times x is x. Negative 2 times 4, negative 8. Okay, so for your prompt / summary, how do these problems connect with the concept of a minor scale? So you want to answer this as they connect by what you do to one side, you do to the other, and doing inverse operation. Okay, go ahead and take out the packet page 3 for the practice. You're going to work on your academic language. This is your properties of equality, so the inverse property of addition, all of your inverse operations, okay? So work on that. We won't do that here on this video. We're going to go straight to the combined like terms concept check. So take this out. So here's your situation. Mr. Epstein is told to take the inventory of how many chairs there are in the classroom. Since the class is being set up, there are only 10 chairs and 3 pencils in the classroom. After Mr. Epstein counts how many chairs there are, he reports to his supervisor that there are 13 chairs in the classroom. His supervisor can't believe that Mr. Epstein teaches math. What mistake did Mr. Epstein make? Go ahead and write your response there. That part I'm not going to do for you. So write your response and then pause the video. Once you're done writing, go ahead and press play again. Okay. So hopefully you paused the video. Now we're on to your partner's response. If your answers are the same, discuss how this relates to variables and exponents or math in general. So since you don't have a partner and are just watching this video alone, so go ahead and try to answer this other question. How does it relate to variables and exponents? Okay, we're going to talk about how this does relate in variables and exponents. So you have this number column here. We're going to put numbers here. Any number you can think of. Try to put some that aren't here just so you can get it. And on this one, all you got to do is put numbers as well, but tack on that x with it. So this has anything with an x. So any big number you can think of, small number, all negatives, all positives, okay? And then the y, same thing. I'm only going to do 3 examples there. 2y, negative 1i, 0y. Actually, the 0y goes in everything because 0 times anything is 0. So we're going to do one more and say 5y. You can do this for x, y's, all of these. Okay? Negative 2, 3, 5, all of those. X squared y, negative 4x squared y, 13 x cubed y squared. So what sets them apart in different columns is the fact that you have these variables. Remember, variables, these are your letters, right? And that's things like x, y, z, any kind of symbol or letter, right? It doesn't always have to be a letter. Later, you're going to be dealing with Greek symbols, and so this is a theta right here. Okay. So over here, the other thing is that it has exponents. Okay, so you have exponents that are also what sets it apart. So notice that, yeah, we have an x here, but I can make a column where it has x squared. Now they're not in the same column because the exponent is different. Okay. Same as, here's another example. Those two have the same variables, but the exponents are different. And if the variables are different, then a different column as well. Well, what's the whole point of even putting them in different columns? Okay. So putting them in different columns is because you can add or subtract, but rows you cannot. Okay. So when they're in the same column, if I did like 3 and 2, I could say 3 plus 2, and now I would get the answer 5. But if I did something like negative 2x and 2y, I should not get 0xy, 0y, 0x, anything like that. I can't get an answer. Basically, this is your answer. It's in simplest forms. Reason why is go back to the paragraph that we were talking about. If I have 10 chairs, 3 pencils, and I add these together, should I get 13 chairs or 13 pencils? No, doesn't make sense. Same concept here. We're categorizing things. So variables go with the same variables, and variables with exponents go with the same one. Okay, so that's what sets it apart is variables and exponents. This is a huge concept that in any math class you're going to have to deal with. Every single one from here to advanced college math. Okay, let's go to the next thing. Scroll down. Okay, now we're on practice. Now we're doing two-step equations. Same exact thing as one step. Before we go there, though, I believe there are some, where is it? I think I scrolled too quick. Here it is, as soon as it loads. All right, here's your teacher-student resource, so go ahead and take this out. So a way to explain multi-step equations. The letter x is a variable. We know that already. A variable represents an unknown value or number. Think of a variable as a bodyguard, protecting the closest number to it. So you have this picture of x as a variable bodyguard thing. So here it tells the 4, stay close 4, I will protect you. And the 2 here is saying, oh no, I'm going to the other side. So here's the actual problem. And the point of this, as silly as it is that you don't want to touch this till the very end. We want to hold this off so then we can do it later. So here we're going to move the thing that is not attached to the variable first. We're going to move the negative 2 here. It's doing the inverse operation, same as what we do. And now we're back to a problem like the one-step equations. 4x equals 4, divide by 4, divide by 4, x equals 1. Take some time to go ahead and read through all your steps. Okay. Okay, so we have our two-step equations here. Let's treat the variable as a bodyguard. So x is your bodyguard. 2 is attached to it. So this is protected. Before we even start, let's go ahead and go through and actually identify where the bodyguard is. This might help you. So if you don't have a colored pencil, let me change to black so it looks like what yours would look like. Go ahead and circle it. Okay, we're circling everything that is protected. I'm only going to do this on the odd side. So I'm going to leave it on those first three. Go ahead and go around and circle everything with an X so you know that that is protected. You're going to do that part last. All right, now that you have done that, go to number 1. We see that this is addition. What is the inverse operation of addition? Subtraction. So I'm going to subtract by what number? I want to move the 3. So subtract the 3 both sides. 9 minus 3 is 6. 2x equals 6. Inverse operation, divide. X equals 3. Okay. Next one, subtract the 3. Subtract the 3. 10 is equal to negative 2x. Divide by negative 2. Divide by negative 2. And x is equal to negative 5. Okay, so now we have x over 2 plus 2 equals 7. So we're going to, let's go back to our pen. So circle this, subtract 2, subtract 2. Okay. If we need to build the wall, if it helps you understand where the boundary is, so this is going to be 7 minus 2 is 5, equals, bring over the x over 2, and change this to a 5 over 1, right? Fraction equals fraction. What do? Cross multiply. So 1 times x is 1x or x. 5 times 2 is 10. Okay. The next one here, 7, is the same as 5. So go ahead and work that out. Make sure you take time to answer the prompt and summary on all of the worksheets for this one and for later sections. They will always have this. So you want to get used to writing for math. So what do you notice about one-step and two-step equations? What do you or do you not understand? Make sure to answer this. Okay, your last part is going to be to go through and answer each of these. This would be your exit ticket. There should be nothing new here. So if you have any confusions here, that means go back and make sure you answered everything right in the previous handouts and worksheets, everything that we went over. Okay, on to the next section.